Hey guys, I thought I'd make a quick video to explain what degrees of freedom means. I think I had somebody ask me that the other day, and I want to make sure everybody's clear on it. When we talk about contingency tables and chi-square tests, you're going to see degrees of freedom come up on exams. And although it's a fairly easy calculation to make, it's important that you kind of understand what they mean by degrees of freedom every time they're referring to it, or every time you're going to start referring to it. So let's talk about degrees of freedom. I'm just going to write it here, degrees of freedom. And we'll discuss what this really means when we're looking at this table, just in case it's not clear. So I've only ever seen this referred to as DF, and that's the same thing your calculator refers to it when you do a chi-square test. So let's talk about that. If we have, I've just made up a mock contingency table is what this is called. It's a table of observed values for a chi-square test. It's referred to as a contingency table. I'm going to actually write that here, contingency table. Okay, so let's say I know the totals. Okay, I'm surveying the number of males and females that prefer Coca-Cola or Sprite. So let's say I'm just going to survey 20 males and 20 females. Okay, so that's going to give me a 40 total people surveyed. And I say of the people that were surveyed, let's say 22 preferred Coca-Cola and 18 preferred Sprite. Okay, so fair enough. So what we're going to do here is we're going to actually write in some values inside this table here of the actual observed values from the survey. How many people, how many males like Coca-Cola, how many males like Sprite, how many females like Coca-Cola, how many females like Sprite. That's important because this is what the contingency table actually is this part right here. Okay, the totals really aren't part of the contingency table, it's just this bit right here. So we can do degrees of freedom automatically. This calculation is going to be the number of rows in that contingency table minus 1 times the number of columns in that contingency table minus 1. So this is a fairly simple calculation. As I see, this is a 2 by 2 table, so I have 2 rows minus 1 and 2 columns minus 1. So this is going to give me 1 times 1, which we now know is 1. That's the degrees of freedom. So that means in my table here I have 1 degree of freedom. I have only one cell that's free to vary, because the formal definition of a degrees of freedom is a number of elements in a system that is allowed to vary and be anything. Okay, so only one of these cells right here is allowed to vary. As soon as I put a value in that cell, the rest of these are known already because they have to add up to the totals. So we already know what they're going to be. So only one of them is going to be an unknown until we put a value down, and that one is free to be different values. That's the one that has the degree of freedom. So if I go ahead and declare that we have actually, let's say, 9 males that prefer Coca-Cola. This one, once I put this value down, I know all the rest of them, right? Because I know that 20 minus 9, right? Okay, that has to be 11. Okay, so now I know that's that value. Now that I know this is 11, I know 18 minus 11 is 7. And now that I know this is 9, I can say 22 minus 9, right, is 13. Okay, so once I put this value down, I know the rest of them. So this was the only value, the first one that I put down, that had any freedom. As soon as I put it down, the rest of them are known. They're not free to be anything else because they have to add up to these totals. So that's kind of what it means to have 1 degree of freedom. And I'm going to go on in a further explanation here. I'm going to kind of change the degrees of freedom. The more degrees of freedom you have in your table, the closer the distribution, your chi-square distribution, will look to a normal distribution from statistics. Okay, so that's kind of important that you try to have, you know, a decent amount of degrees of freedom. In fact, if you have anything less than 2, you're not going to be able to do a chi-square test anyway. This sort of test right here should never be done, honestly. But we'll talk about ways to to kind of sort out if you can't get a very big degrees of freedom in your table. In some cases, there are some modifications to the calculation we can do, like called a Yates correction, but we'll talk about that in class. But for the time being, I'm going to make another table here with a different degrees of freedom, and I'll show you the same calculation and why it varies. The degrees of freedom is different from this one. Okay, so let's just move on from there. So I hope that kind of makes sense. Alright guys, I'm going to move on from this and get to a bigger contingency table, which will change our degrees of freedom. So if we look at the actual contingency table part, this bit right here, not including the totals, right? This is a contingency table, so we're going to do degrees of freedom calculation, which again is rows minus 1 times columns minus 1. So as you can see, we have 2 rows, so it's 2 minus 1, and we have 3 columns, so this is 3 minus 1, which will give me 1 times 2, which is 2. So this actually only has 2 degrees of freedom, this table right here. That means cells inside of this table will actually have freedom to vary. And once they are determined, the rest of the values will be known. Okay, so let's go ahead and just make up some totals here. Again, let's say if we had surveyed 20 males and 20 females, and we have a total of 40. All right, and let's see if I have like let's see, 20 like Coke, 12 like Sprite, and 8 like Dr. Pepper. All right, so when we add this together, of course, it'll give me 40 as well. Okay, so I need to actually come up with a value for Coca-Cola here, like males. So we have like 2 cells here that are free to be whatever, as long as it's not greater than 20 here, and it doesn't exceed the columns of the row total. So if I actually say that there are 8 males that like Coca-Cola, okay. All right, so now that I put this value down, okay, this value is already known, okay. So this was a free value. It could have been anything at once, okay. So that's one of the degrees of freedom we're going to use up right here. And once this is placed, we already know this value now. Okay, this one has to be 12. Now we have 4 spaces left, but like I said, 8 plus 2 different numbers equals 20. So we have another degree of freedom because this next cell can be a number of variables. It could be a number of values. It can vary from anything from from 12 to nothing, from 0 to 12. So if I said 8 plus 12 is 20, that would have been it. It could be 0, it could be 12, it could be any value in between them. So we don't really know what this next value is, but as soon as I write it down, though, we're going to know all the rest. So this is the only value now that is free. This one was free before. Once we placed it down, we knew this one. This is the only other one right here that's free. Or we could put any value anywhere else. But there's only one more value that's free after this one was used. So if I put that free value here, let's say this is going to be 6. Now I've used up my 2 degrees of freedom. Now I know the rest of the values already. No other cell can be free. It's not free to be anything else. Now it's determined that it has to be a specific value. So it's not free to be, a range of values. Now they have to be specific values. So if I say 8 and 6, right, that's 14. So I know another 6 will give me the 20 that I want. I know 6 plus 6 will give me the 12, and I know 6 plus 2 will give me the 8. So now I don't have any other options here. Okay, I have this used. So what I'm saying is I didn't know this one at first, and when I put it down, I knew only this value. But then when I had this 4 spaces left, I had another degree of freedom to use. Once I used up this one, I'm out. I know the rest of the values are not free to be anything else. This has to be 6, and this has to be 6, this has to be 2, once I put down these 3 values into the table. Okay, so once I use this one and this one, really, I knew the rest of them, because these are the only 2 that were technically allowed to be free. And as soon as I put values in for them, the rest were known. Okay, so that's kind of how it works when I say there's 2 degrees of freedom. Once this one was known and this one is known, we know the rest of them. Okay, and these are the only 2 values that I was considering to be free. I kind of hope that makes sense. So that's what you're talking about for degrees of freedom. If you do a calculation like this in your IA, I suggest you have some brief explanation as to what degrees of freedom means in your IA. Okay, it's not a bad idea. If you do a chi-square test, you definitely have to calculate degrees of freedom anyway. So offer an explanation. Don't just do a calculation in your paper and not tell the moderator or tell me why you did it or what it means. Okay, because it's important that you indicate that you know everything that's going on. All right, so I hope that helps. I'm going to be making videos on chi-square tests this weekend, so I hope you're watching all of them. You really need to watch all the videos that I'm posting. Even if you don't do these processes in your IA, they're important to watch because they're going to help you on your tests anyway. Once you understand how the processes work, it's going to help you on your exams, and that's just as important, if not more important, than the IA itself. So anyway, I hope that helps out. Good luck to you. And again, keep watching videos, and I think you guys are going to be really good this year, so no problem.